very good practice to wrap your head around. Okay, when you look at the new sphere and the original, right? You gotta look at these correspond, right? The volumes would correspond, the area or surface area would correspond, right? And here you have your radius, right? Both radii, right? You know them both, right? So that's how you're gonna get your scale. That's how you're gonna get your scale. So remember, scale factor is always new over original, correct? In general, that's what it is. So to find the scale factor that would take us from the original to this one, which is in our case the smallest sphere, we would just go k is equal to radius of new divided by the radius of the original. In this case, you're always going to use new original, right? That's what we're going to stick with. Let me zoom in a little bit because I feel like it's very small at this point. Okay. So there we have it. That's how I'm going to get my scale here. So are these both one-dimensional, would you say? Lots of giveaways, radius, right? We can measure it. This is just a length. Another giveaway is that both units they have an exponent of 1. You don't see it, right? But inches, not inches squared, inches cubed. So we don't need to worry about putting a power here, okay? So we go, radius of the new one is 1.35 inches divided by 7.5 inches. No conversion needed. And all I need you to do here is get me the decimal or percentage. I think I'm fine with either or, right? I'm going to use the same calculator as you. And I will give you the key to this later. Okay, so we divide them. That'd be 0.18, right? Or 18%. Does that make sense how we just did that part? We got our scale factor. That's like the key to everything else. We can now use the scale factor to find our missing area, to find the missing volume, right? Because we know how are the areas related by a factor of k squared. And the volumes are related by a factor of k cubed, all right? So watch this. Way up here, you're going to go k squared is area of new, area of original. I tried to give you enough space, but you have to be careful here. It's a little messy. It's a little tight. I know that. So, do I know my scale factor? It's right here. Right? Do you want to use decimal or fraction? It's up to you. I'm going to go with 0.18 squared is equal to, I don't know the area, right? So I'm going to call that x. Do I know the area, surface area or area of the original? You bet. It's right here, 706. Look at the mouse, right? It's pointing at it right there. Okay, 706.86 squared inches. And if you square 0.18, use all decimals, right? 0.0324 is equal to x over. If you want a piece of loose leaf and do this on loose leaf and then just attach it later, sure. I will allow you to do this. Don't show your work, just go like that, right? So that times 706.86, that's 22.90 squared inches. I'm handing it off to you now, except for I'm going to add this one more. K cubed is volume of new over volume of original. What are you going to have to do there? Cube your scale factor. Okay? Cube it. One more thing, guys. Are you listening? The first thing you always need to find for every single one of these is what? Scale factor. That's your key. You need to find the scale factor. You may have to square root. You may have to cube root. It depends on what are you relating. Okay? So off you go. Try to fill that in. Good practice. I'll be bet you know how I got there. So for this one, I have the two areas. So if you want to skip to the fact that you need to square root the new and the original, then by all means go ahead and do that. I am picky if you keep, like some students keep the k squared, even though they square root it. So you'll lose half a mark for notation there, right? So you gotta watch out. When you square root, you're actually square rooting both sides. That's why you get rid of that to the power of 2 here. Okay. So this gives you 0.6, right? I'm just gonna double check because every once in a while, did you get 0.6 or 1.6? 1.6? 0.6? What am I doing wrong? New. Okay. That's when I go off script. That's what happens. So yes, you're right. Thank you. Was it Luca or Viraj? Viraj, thank you. I appreciate that. I had in university super smart math professor. Okay, he would just came in, everything was in his head. So he would do this massive equation on the board, and he got to a point he just froze. Like, guys, I can't do this, and he just walked out. And we're just like, what now, right? So that was an early dismissal, I guess. So it happens sometimes. We're all humans. So I guess the way I showed it to you, right, is to maybe divide first, because we have these calculators, right? And then just divide, and that's 0.6. There it is. Yeah. So this would have been square root of 0.36 continued, and then you get your answer there. So that's how you got the square root, the scale factor there. And then this one here, the very last one, you needed to cube root, right? And if you do this right, some of you on the quiz, you show the root, you forget the index. If your final answer is right, I'm okay. Like I get it that you did take the cube root. So let's get this right, okay? New over original. 27,611,65. And then this would be 1767.15. When you cube root that, let me just divide that, and then I got to go math 4 of my answer, and it's basically 2.5, right? So there you have it. And then the rest you just fill in, and I will just give you the answer so that at least you know you did it right. So this would have been 10.31 cubic inches. This would have been 381.70 cubic inches. And then when you go over to this here, the radius is just 4.5 inches. And then for number 4, For number 4, we have here the area would be 1104.47 square inches. And the volume is 3451.46 cubic inches. And here the surface area would have been 4,417.88 square inches. Ouch. I have some anger issues, pressing too hard on that. And then the radius here is 11.25 inches. Okay. So very important to know how to do these. Will there be a table on the test? I won't tell you, but you should be prepared to answer something like this. It probably won't be this busy, right? It might just be one line you need to fill in, but it still just re-emphasizes, you know, if you know these 3 formulas, right? If you know these 3 formulas, I can give you any 2 pieces and you find the missing piece, right? Okay. All right. So if you want more of this, just to practice, I think pages 9 and 10 in the workbook will do the trick for you. Let me just check to see what they look like. 9 to 10. 9 to 10. I would say I will change that to say, look at 13, looks exactly the same. I would change that to 11 and 12. Okay. So just in general for quiz and everything, cross this out. Okay. For test, I mean test review, page 11 to 12. Okay, page 11, pages 11 to 12. And I will post the key to that. I think I may have done that already, but here it is re-emphasizing it. Okay. So I might bring all the keys that I posted over the days. I might bring them all up to the top. So if you want to go through the book and just have the keys readily available, you can do that. Okay. I still want to talk. Some of you watched it. Whoever did, you know, you did your work, you did your part. I talked about, I think it's page 16 or 17. Let's go back a little bit. It was 17. And I don't know if you noticed, but I was being interrupted. Like the one day, right, where you want to make a video, you're being interrupted by students having questions, which is fine. But, page 17, this is page 17. And if you watch this, then you will have this in your booklets already. So they ask for the scale, no problem, right? I take the length of the actual pool and relate it to the length of the diagram. In this case, diagram actual is the way to go. You can have different units, just not decimals. Remember that. Perfect, that's it. The scale factor, I compare inches to feet like this. I can't have that. So I converted the feet to inches, brought it back in here, and then you get this fraction, decimal percent. And you know it's a reduction, right? Because K is less than 100%. So from the actual, we went down. And I think the most important part of this page is perhaps, and this is where some of you got this wrong on the quiz, and I think I'm going to make this worth 24, the quiz 24, because I feel like I didn't emphasize that enough. All right, so your mark will actually go up by a little bit. Since the diagram, it says here, how much smaller or larger is the model? How much smaller or larger is the model? And watch this, see here. I explained that since the diagram has been created using a scale factor of 12.5%, I find it easier to answer this question when it's as a percent. Okay. And watch this, K is less than 100%, which resulted in a reduction of the actual. It's always asking what happened to the actual or what happened to the original, depending on the wording. So it means that 12.5% of the actual remains. Okay, so in a sense, to answer this question, right, you need to take 100%, which is the original or the actual, and you subtract what is left, and then you know your answer. It's 87.5% smaller. It shrunk by 87.5%. So this is the new piece here that perhaps needs to be addressed, right? I will give you a summary in a bit on this one. So I'm kind of getting you ready, kind of just tying up any loose ends, okay? I'm trying to bring it all together so when you go through this booklet and review, you're ready. So the actual pool has been reduced by 87%, 87.5% to be specific. And if you watch this whole lesson, like I did explain this bar here a bit more, okay? So I'll say this. To summarize, right? If K is, let's say, 130%, you figure out that the scale factor is 130%. Okay? It means that there is an enlargement of how much percent? If it's 130, how much should it go up by? Right, from 100 to 130, so 30%. Does that make sense? 100 is your baseline, 30 of 30%. Okay? So I went 130% minus 100%. That's how I got that 30%. Okay? If K is, I don't know, 60%, it means that there is a reduction of, any brave volunteers? 40%, right? 40% reduction. Aha. So it's 100 minus 60, that's 40%. So 100 is your baseline. What happened? Am I, right? Oh, my scale factor is 60%. That means that it 40% reduction, right? 130%. Oh, I'm 30% above the 100, right? So always base it, always based on 100%. And this is my actual, the actual car, the actual pool, the actual building, whatever, or the original. Right? We always base it on the start, right? Okay. So that's all I have to say about this part. And I'll tell you this, the quiz checklist is the same as the test checklist. Like everything that was on the quiz, obviously different questions and stuff like that, but pretty much everything is going to be the same. And I will go over the quiz, so in case you're wondering, what about the quiz, right? It's happening. It's happening. I will strongly encourage you to, if you haven't done so already, because there's a reason I spent the time to make the video, right? Page 24. Based on the views, there's still 10 or so of you that need to do this yet. And that's the toy card question. Can I say something about this one? It's basically the chart you were just doing. It's just not a chart. It's a word problem, right? But in terms of how we solve everything, it is exactly the same. We first had to figure out the scale factor, and then we could figure out length. We could figure out surface area, and we could even figure out volume if that had been unknown to us, right? So this is a good one to make sure you watch. All right. And these textbook questions are good, and I may have already assigned some of these, but if you need more, then that's where you get it. But I would say, I'll just do this again here, plus page 11 and 12 in the workbook. This is the whole package here, basically. Right? If you want to do test review. Test review, and that's where you get it. So you have all the ACs that we did and I returned. You've got the quiz, you've got the booklet, you've got videos, list goes on. I'm going to stop this one here and make a separate video.